Welcome back. Here's the question we're dealing with now. Calculate the total displacement for the following motions with both equations and vector diagrams. So we're going to be drawing some vector diagrams in this video too. For the first movement, we are traveling 8 meters north and then 5 meters north. Okay. So, part A. Also, it's actually very important for us to draw out our compass rose. Okay. And for part A, we're starting at some origin and we're moving 8 meters north. So we'll say this is our first displacement of 8 meters towards the north. And then we're traveling even further up, not the same amount, so we'll make this a little shorter, and we'll say this is our displacement, our second displacement actually, at 5 meters north. Okay. So how do we get the total displacement then? Well, that'll be delta dt for our total displacement. And what we want to do is we want to do some vector addition. So we're essentially adding these together and seeing what our final displacement is. Okay. And I think it'll make more sense as we go through the questions as well. So keep watching and you'll see what I mean. Delta d1 plus delta d2, we're adding those. And let's just write in 5 meters north plus 8 meters north. And this is where we want to choose a positive direction. So in this case, let's say north is our positive direction. So everything that's north, we're gonna take the direction out. We're gonna turn to a scalar, and we're gonna make it positive or negative. Okay, we're gonna write them as positive or negative. In this case, it will be positive because both of these are north. So 5 meters plus 8 meters. And that should just give us 13 meters. Okay. And since it's positive, 13 meters towards the north then. And that is our total displacement. Okay. Awesome. On to question B. Question B says that their first movement is 8 meters north and they travel 5 meters south. So in this case, we're starting at some origin. The first displacement is 8 meters towards the north. And then we're traveling back down about 5 meters towards the south. So our displacement 2 is equals to 5 meters in the south direction. Okay, so let's keep the same convention as we did last time, so that we'll say north is positive. Okay, and we'll write our equation again. So the total displacement is still the first displacement added up with the second displacement, and you'll see how this works if you don't see it already. Okay, we're gonna put in our displacements. So we have 8 meters north and 5 meters south. Now what we do is, since north is positive here, all the north directions, we're going to take out that direction and turn it into a scalar and make the number positive. So we're going to leave this 8 as just 8 meters. But now with the second displacement, well, it's going into the south, which means it's going to be a negative number. So we're going to turn the 5 into a negative 5 meters, just like that. And I like putting these into brackets so we actually see where the negatives are, and so that you guys can see that it's still, we're still adding it, we're just adding a negative number, okay? It's not that we're subtracting. We essentially are subtracting, but it's more or less the negatives coming from the displacement going south. Okay, and that's what I wanted to show there. That's why I did it like this. Okay, so if we carry out the arithmetic, then this is 8 meters. And since it is positive, or sorry, not 8 meters, 3 meters, and since it is positive, it is 3 meters north. Okay, and that is our delta dt. Box that answer off. Awesome. On to question C. Question C says the first movement is 25 meters east. The second one is 10 meters west. So we start somewhere here. We are moving 25 meters east. Like that. We'll say that's our delta D1, 25 meters towards the east. And then we move about 10 meters west. So let's say it's about that much. 10 meters west, just like that. All right. So we write our equation again. Delta D T for the total displacement is the same, or is equal to the first displacement plus the second displacement. So what direction do we want to be positive here? Let's say the right is positive. East. It really doesn't matter what direction is positive. I'm choosing the right to be the positive direction because I know that the displacement, which is this part here, will be in the right direction anyway. If you choose the left as positive, that's totally fine. You might end up with a negative number in the end, but that negative number is just going to be translated back to a vector, which will have a direction anyway. And that's what the teacher really wants. So it really doesn't matter what direction is positive, okay? So let's start plugging numbers in. 25 meters east plus 10 meters west. East is positive, so we leave 25 as positive. And the 10 is going west, so that's going to be a negative now. This should give you 15 meters. 15 meters. Positive number, that means it's going east. Delta dt. There you go. All right. On to the last question now. Probably the hardest question of them all, so if you can do this last one, then I think you're golden. Now they give us 3 movements. There is 6 kilometers south. Then we're moving 14 kilometers north and 3 kilometers south. So let's say we start here. We're moving 6 kilometers south. So delta D1 is equals to 6 kilometers south. And then we're moving 14 kilometers north. So it's something like this. Okay. Let's move this a little more to the right. And afterwards, we're moving 3 kilometers south again. So it's probably something there's not a lot of displacement there, but D3 is equals to 3 kilometers south. Awesome. Okay. And overall, our delta dt is our delta d1 plus our delta d2 plus our delta d3. Okay. And what direction do we want positive? Well, I don't know. We'll do plus, or sorry, not plus, but north is positive. Okay, there we are. And make sure in every question, this is stated. Okay, I've seen students lose marks for it, so always state that. Okay. Now let's fill in our numbers. We have 6 kilometers going south, plus it'll be 14 kilometers north. Okay. Plus 3 kilometers south. We chose north to be positive, so this is just going to be negative 6 kilometers plus 14 kilometers plus negative 3 kilometers. Okay. So then we would just plug this into your calculator if you'd like, or just do mental math, and you should get 5 kilometers. Okay, in the positive direction, which is 5 kilometers north in this case. And we also want to always leave our answers in SI units. In physics, we don't want to leave it as kilometers. For displacements and distances and positions, we want meters, which is why I haven't been converting the other ones to anything, because they're already in meters. But what would we multiply this by? And if you remember the last video, I think it was the last video, maybe the last few videos back, I like doing it this way, where I multiply it by a conversion factor. And the conversion factor between kilometers and meters is 1 kilometers is 1,000 meters. Okay. And I want meters. I want my final answer to be in meters. So I want the kilometers to cancel out. So I'm putting that on the bottom. And I'm leaving 1,000 meters on top. That cancels out. And I am left with 5,000 meters. And it's positive, so we will say it is in the north direction. Okay. This is delta dt. We can box off our answer. I do also want to say that this might be an easy conversion from 5 kilometers to 5,000 meters. But the reason why I teach it this way is because later on in physics, it might not be in this class, maybe it's the grade 12 class, it might not even be in physics, it might be in chemistry, where you're converting units so much in an equation that sometimes it's fairly hard to keep track of everything, right? And sometimes we're not 100% sure about what the conversion factors all add up to, since there's so many that we're using in an equation. By doing it this way, it is foolproof. If you do it this way and you do it right, I guarantee there is no way to mess it up in finding out what the conversion is between displacements and positions, velocities, whether it be maybe other units even. And what you're trying to find, right? And what the scales are. So try to do it this way. I don't think a lot of high school teachers teach it this way, but they also start doing it this way in university, and I don't think it is actually difficult. I think it actually makes things easier. So try to do it this way, and if you guys like it, I'll continue doing it this way on the videos. All right.